This is our third video for circles, and in this video we shall write the equation of circles from general form to standard form. The key to doing this is completing the square. We did this in parabola, and we shall do this again when we go to hyperbola and ellipse. So example 1.16, reducing general equations to standard form. So we have an equation of a circle that is written in general form. How do we obtain the standard form? So the standard form is the one that shows the center of your circle. Let us put the x's together and the y. Let us transpose the constant term. So let us transpose the constant term there. Okay, so pay attention to the coefficients of the linear term. This is the linear term because this is a degree 1 term. This is a linear term because this is a degree 1 term, and the coefficient is -8. We shall need it for completing the square. So what you will do is you will divide 4 by 2, and then you will square it, and then you will add it to these two terms. Okay, that's what we did here. For this one, you divide. Okay, so the coefficient here is -8. So you divide -8 by 2. That's -4. And then you square it. And then you add it to these two terms. Okay, so in effect, we added 4 and 16 to our terms here. You must do the same to the other side of your equation. Again, that's basic. That's basic solving equations. Okay? So if you want to keep the equation or the equality, what you did here, you must do that. So we must add also 4 and 16. So this one can be now written as the square of a binomial. Okay, so the reason why I didn't write that as 4 right away, because I want to see number 2 there. I want to see number 2 there. Because I will need it when I write the equation in standard form. X plus 2 squared. The same with -4. I did not simplify this right away, even though I know it's 16, because I want to see that -4 there. Okay? Because our equation in standard form would be in this form. The quantity y minus 4 squared is equal to, we simplify that, that's equal to 25. Okay, so in the book, we are not required to identify the center and radius, but just to practice interpreting an equation, what would be the coordinates of the center of this circle? So what do you think? It's -2 and 4, and the radius is the square root of 25, which is 5. Again, reducing general equation to standard form. The standard form is the form that shows the center of your circle. Okay, so we put the x's together and the y's together, and we transpose the constant term. Pay attention to the coefficient of the linear term. The coefficient here is -5. The coefficient here is -3. Again, why do you call that the linear term? Because it's a degree 1 term. Okay, so this one is the quadratic term. This is the linear term. Okay, again, we divide -5 by 2, and then we square it, and then we add it to the two terms. The same with this one. -3 divided by 2, we square it, and we add it. We add it to y squared minus 3y. Now, you might be tempted to write this right away in decimal form. Okay, so that's fine. Okay, if you want to write this as -2.5, that's fine. This one is -1.5, but you can leave it as a fraction because of this one, because we shall add fractions here. This one is written as a fraction. So it would be easier if you leave this as a fraction. Okay, so what is this? This term is equal to 25 over 4. So we must also add 25 over 4 there. This is equal to, the square of that is 9 over 4. Okay, that's 3 times 3 over 2 times 2. So this one can now be written as the square of a binomial. Okay, so I am not simplifying this right away because I want to see this. I want to see this. Okay, so that I can write it this way. Okay, so we simplify this. This is, okay, negative 26 over 4 plus 25 over 4 plus 9 over 4. That's 8 over 4. Okay, so that's 9 minus 1 over 4. 8 over 4 is 2. Okay, so we are not given the instruction to identify the center, but let's do it anyway. What's the center? It's 5 halves and 3 halves. And our radius is not 2. The radius is square root of 2.